So I would request all of you to stay and then we break for lunch. So please do sit back. This next session is about achieving software sustainability, and many of you might be in this business. Can you all sit down, please? We request all of you to just be a part of this session with us. Our next speakers are already ready. Today's session will focus on achieving software sustainability without compromising business goals, as well as exploring the role of green technology in software engineering to help attain carbon neutrality. For this session, excuse me, I would request all of you, if you're speaking, to please go outside. Otherwise, please settle down for the next session. All the speakers deserve the respect that we can give them. Thank you so much. For this session, we have three incredible women from Goldman Sachs. Going first is Sonali Patel and Nishi Chauhan, who will discuss how to achieve software sustainability without compromising on business goals. Sonali is a software engineer with 2+ years of experience, currently working in site reliability engineering, focusing on automation, observability, and resilience for products and infrastructure. Passionate about diversity in tech, even outside of work, she is engaged in promoting diversity in tech, enjoys reading everything from fiction to tech blogs. Nishi Chauhan is working as a software engineer with Goldman Sachs for the past 2 years on observability products to enhance infrastructure reliability. Prior to this, she was with American Express for 2 years. She has recently found her interest in sustainable tech solutions. Apart from work, Nishi loves to meet new people, explore great food, and new experiences. Put your hands together for Sonali and Nishi Chauhan.
Good afternoon, everyone. It's great to be here to discuss an increasingly relevant and important question of the hour. How can organizations achieve sustainability without compromising on business outcomes? So, as the global push for eco-friendly practices accelerates, companies need to strike a balance between environmental responsibilities and financial growth. So, could you move the slide? More? More. So, in this session, we'll cover some actionable strategies to align sustainability with business objectives like resource optimization, reducing waste, and leveraging green technology. We will also cover some open source tools that are available in market that help you measure and set and track your custom SLIs and SLOs that focuses on metrics that will help you to support both sustainability and growth. But have you wondered why are organizations not investing in green software foundation? Often, lack of long-term benefits awareness along with some immediate focused returns create barriers. For developers, these challenges are compounded by the lack of sustainability focused tools available in market along with fast-paced delivery environment. In this session, we'll try to come up with some actionable strategies that will overcome this hurdle and help us to focus on more sustainability.
Hello? Yeah, let's talk about business objectives first, which focus on measurable goals to improve efficiency and effectiveness of your system. Efficiency means delivering high quality output with minimal resources to improve cost and, generate a successful product. Efficiency, on the other hand, means how well your software is fulfilling its intended purpose. It is measured using SLIs and SLOs. SLIs represent numerical indicator for reliability, and SLOs are a set of threshold that you set for acceptable performance. Now, let's pivot a bit to greenness, right? In this talk, we'll talk about two major types of carbon emissions: embodied carbon, which is emitted during the production and disposal of materials like hardware, and electricity induced carbon, which is produced during the generation of electricity. Coming to sustainability objectives, what are those for a firm? It aims at reducing the carbon emitted by your software, right? And you do this by enhancing the greenness. How do you define greenness? So we have come up with two terms: tangible and non-tangible greenness. We'll one by one go through this. So tangible greenness is the measure of number of resources your software utilizes to run. So by using fewer machines and hardware, you are reducing the carbon emitted by this hardware. And not only that, you are reducing the cost of that hardware, which directly translates to business efficiency. Second, non-tangible greenness refers to how productively you are utilizing the underlying hardware. Think of it in terms of computational overhead and memory management. So it directly aligns with business effectiveness. And just as we measure the reliability or effectiveness using SLIs and SLOs, we propose using green SLIs and SLOs to measure, monitor, and track your system's greenness. Yeah. So in an ideal world, we would want developers to consider greenness as just another metric like cost, reliability, and security when you are designing and developing your application. But it's not an ideal world. So our goal is to, make it easier for developers to use, to, integrate greenness at different stages of SDLC. And we'll do this by giving examples of tools and frameworks and different methods you can use at different stage. Let's start with the design phase. Now, many decisions you'll make here will either increase or decrease the greenness of your software without even realizing it. Think of it like you have developed a kind of inefficient system which takes excessive CPU and memory. So not only it will affect the overall performance of your system, but it will also take a lot of hardware to run, and again it will decrease the tangible greenness of your overall system. But that also doesn't mean that every efficient system is a green system. Think of caching as an example. While caching will reduce the latency and increase the performance of your system, at the same time you're adding another layer of hardware to your system, so again it will decrease the tangible greenness. So, yeah, it's all about making an informed trade off. The second thing I want to talk in this design phase is software architecture. Well, we talk a lot about monolithic and microservice architecture at this phase. While monolithic architecture tends to be more green in terms of interprocess communication because because it is faster and uses less energy, microservice architecture offers us flexibility and scalability, which we can use to optimize individual component or individual service in our system, and therefore reducing the risk of hardware provisioning. In this way, we'll improve tangible greenness. So when you're considering between monolithic versus microservice, take into consideration greenness also as a factor. And third thing I want to talk in the design phase is data storage. It is crucial to consider what you store, where you store, and how you store it. What you store. Please don't store anything that is not needed. It will just decrease the tangible greenness of your system. Where you store, it is important to consider having your database nodes closer to your application nodes because it will reduce the number of network hops and therefore improving the non-tangible greenness part. And how you store. So, think about data compression techniques while storing the data, which will reduce the number of IO operation and also database maintenance cost. So you'll improve both tangible and non-tangible aspect of your system. Let's come to the development part of SDLC. Here, very crucial is the choice of programming language. In this study, it was found that low-level programming languages like C and C++ tend not only to be much more time and memory efficient, but also energy efficient. Now, I cannot ask all of you to just go home and rewrite all the codes in C and C++, right? So we are here with two practical approaches. The first is you can use compilers. So there are a lot of open source tools which translate your code written in high level language to low level language. Some examples are Python and Shedskin, which compiles your code written in Python to C or C++. The second approach is upgrading the version of your current language to the latest one. So let's say if you're using Java 17, upgrade it to 21, because it is found out that the later versions of the language tend to be much more green and also efficient. These kinds of upgrades are low-hanging fruit that you and your firm can easily adapt without overwhelming your resources and system, and could be like a practical starting point to start your green journey. Right. So here are the tools listed on this slide. All of them are open source, which you can, integrate with your code to determine and measure the greenness at the development phase. So let's say if you're using Java, there is JReferral. If you're using Python, there is Code Carbon, and so on for websites, for Android applications. Regardless of the language you're using, there is a tool out there. And not only that, some tools go one step forward and give you optimization recommendations. So how can you further optimize your code to increase the greenness? Yeah, that's all for design and development part.
Okay, so let's dive into how we can improve and measure sustainability in deployment and post-deployment phases. So starting with machine utilization, also known as server density or bin packing, it is a concept of maximizing the available resources like CPU, memory, I/O, bandwidth, and power usage on each machine so that you can reduce some waste and make your infrastructure more greener. But let me ask you a very simple question. So how many of you have spent some time to rewrite your code to make it more better? Raise hands. Almost everyone. So let us take an example. So imagine you spend months of rewriting a code to reduce your CPU usage by 99%. Sounds great, right? But if you're running it on the same oversized server, then the energy and the environmental cost barely changes. This is because partially utilized machines uses nearly same amount of energy as the fully utilized ones. Also, you're dealing with the embodied carbon of that hardware. So that is where right sizing becomes critical. So right sizing ensures that your servers are optimally sized to handle the workload. But right sizing or getting that size right could be very tricky. And that is where many teams try to over provision the system to have larger machines to have handle workload when the demand spikes up. So to tackle all of this, we have another solution called auto scaling, which the idea behind auto scaling is to adjust the resources based on the demand. But um, so we scale up when the demand goes high and we scale down when the things are quiet. But scaling down is often perceived as risky and is often handled manually by many teams, but it defeats the overall purpose of auto scaling. So auto scaling does not always solve the underutilization problem fully. We have another powerful approach called cluster scheduling. So the idea behind cluster scheduling is instead of assigning one application to one server, we are going to club many applications and put them on these fewer servers to make the most of the available CPU, I/O, and everything. So this is going to make sure your servers are efficient and resource optimized. So for example, if you have one application which is CPU intensive and there's another application which is IO intensive, cluster scheduler would try to club them together and put them on the same server, ensuring that your resources are optimized, making the most of the available resources and minimizing your cost. It would also require, cluster scheduling also requires you to encapsulate your jobs into containers like Docker and label your workloads with the particular resource requirements so that whenever there is any kind of workload that comes in, cluster scheduler will be able to allocate those resources accurately. Let's also talk about zombie processes. So what are zombie processes? These are remnants of applications that have finished their jobs but are still using your CPU cycles and memory. These do not perform any useful work, but they yet add to your carbon footprint. And they are also security liabilities as they increase the surface area. So eliminating these jobs would not only reduce your carbon footprint, but would also make sure your application is secure enough so that we bring closer to the sustainable ecosystem. So when it comes to tracking and measuring carbon emissions in cloud, there are many tools that stand out for the unique contributions. Starting with cloud carbon footprint, which converts the cloud user provider data into energy and also consider power usage effectiveness of cloud providers' data center to make us understand where these emissions are coming from and how do we reduce them. Next, we have Kepler, whose full form is Kubernetes Efficient Power Level Exporter, which uses eBPF, which runs the system in a privileged mode to collect these system metrics that helps us to export them to Prometheus for visualization purposes. We have KubeGreen as the next tool, which is essentially a Kubernetes add-on, which will stop all the pods that are not in use in a particular namespace so that you reduce the idle consumption and use resources only when it's needed. Lastly, we have Green Metric tool, which is a holistic framework of CO2 energy application to measure your CO2 of your application. And it receives energy resource consumptions and gives them as a metric. So here are some dashboards that are getting created using some of the tools. So on the left, you see there's a Green Metric tool dashboard, which has all the information that it got using one commit. This tool will also enable you to compare between two commits, how much your carbon emissions are changing, just to make sure that how your carbon emissions change with one push of your code to help you make more aware. On the right, there's a Kepler tool dashboard, which shows you different pod level metrics that are related to CPU, GPU, and RAM. And it would also support both bare metal as well as virtual machines. So to track your progress effectively, you can add some green SLIs and SLOs on this. You can also add some alerting features here, which will help you to get these updates in real time. That will help you to be on track with your eco-efficiency goals. So here's this case study that somebody did, which was related to KubeGreen results. So as I told you before, KubeGreen will automatically shut down all the pods when they are not needed. So as you can see on the screen, this is a comparison table, what happens when we use KubeGreen and what happens when we don't. And you see that for a week, the carbon emission equivalent got reduced by 83 kilograms. And that computes to 4,316 kilograms in a year, which is really huge.
So, yeah, with all the tools and resources available, many organizations out there are still not aware of green software practices. And the ones that are aware find it time consuming and complex to implement. It is important to understand that green software is not overwhelming, and in the long run, it will go hand in hand with your business, as all good practices always do. So, yeah, we wanted to conclude with saying that environmental friendly computing is not only effective, essential, is not only feasible, but also effective, essential, and efficient. Yeah, thank you.
That's okay with everyone. Don't need this. Okay, next we have Madiha Qureshi. Sorry? Oh, sorry. I'm really sorry. I thought I'll call three of them together. You guys will be here, right? Yeah, okay. Madiha is an enthusiastic software engineer with 3 years of experience in the industry. Originally from Ujjain, Madhya Pradesh, she carries the warmth of her hometown wherever she is. Moving from there to Bangalore, she observed how rapidly cities are evolving and affecting the environment around them, which sparked her interest in how technology can contribute to sustainability. Fun fact, Madiha enjoys fitness, food, and travel. Exploring new street foods or experiencing different cultures, she thrives on pushing herself beyond her comfort zone. And I really thank you for being with us today, and please welcome to the stage. She's going to be talking about the green software recipe. She likes food a lot, so it's going to be a recipe. Design patterns and practices for sustainable software.
Cool.
Welcome.
Thank you so much.
All right, let's consider this. Every line of code you write, every query you fire, every framework you choose converts into carbon. Despite its seemingly intangible nature, information and communication technology contributes to 3.9% of global greenhouse gas emissions. To put that into perspective, it is at par with the aviation industry. Shockingly, this figure has increased about 2.5 times since 2007, and if we continue on the same trajectory, it is expected to increase by 14% in 2040. This should be a wake-up call for us. The tools and technologies we build to drive our digital future are silently fueling the climate crisis. In the face of escalating climate change and environment degradation, the need for sustainable practices in technology development have never been more critical. But no worries. Today I'm here to talk about how we, as software engineers, can rewrite this narrative and take responsibility of the environmental impact of the software products we create. Allow me to introduce green software engineering. It's a comprehensive solution that addresses all the environmental concerns we just outlined. To put it simply, green software is a software that is carbon efficient. It emits as least carbon as possible. But now let's explore some more comprehensive definitions. A green software is produced to meet sustainability objectives. It has minimal negative impacts on the environment during its development, deployment, and usage phases. It also incurs minimum usage of natural resources. Ideally, a sustainable software's functionality should reinforce sustainable development or at least has no negative impacts on the society or the environment. Building on that, we can define a sustainable software process, which is the consideration of environmental impact during the software development lifecycle. And similarly, green software engineering is the art of developing software using a sustainable software development process. The software thus created is continuously monitored, measured, evaluated for its negative and positive impacts on the environment, and this data is then used to optimize the product further. We shall now look at some principles that green software engineering adheres to. Energy efficiency. It is the cornerstone of green software engineering, and it aims to minimize the power required to run a software. This is done by writing algorithms that optimize code and reducing resource-intensive processes. And it also helps to reduce the power consumption of the hardware that the software runs on. Minimal resource usage, by resources I mean CPU, memory, storage, network bandwidth, which helps to gain energy efficiency and also extends the life of the hardware that it runs on. Carbon awareness simply means that do more when the electricity is cleaner, do less when the electricity is dirtier. And by clean and dirty, I mean renewable and non-renewable sources. Hardware compatibility. Creating software that also runs on older hardware will ensure software longevity, and the use of hardware that has the minimum embodied carbon possible is encouraged. Green data centers. When hosting your softwares, choose data centers that use renewable resources to power them. Data centers that use intelligent load balancing techniques and dynamic resource allocations to minimize the idle power time of servers, and data centers that use virtualization to reduce the number of physical servers required, which in turn reduces the cost of cooling. Minimal data transfer. When we reduce the volume of data being transferred over a network, we not only save energy, but we also elevate strain on the network infrastructure. Some techniques that can be employed to achieve this are data caching, use of data formats, and data compression. User education. It is important to assess how users are using your software and educating them on how to use it more effectively. Eco-algorithms. As we all know, bloated and poorly designed algorithms can reduce performance, and today I'm telling you it also increases the energy consumption of your software. So green software engineering encourage us to optimize our algorithms by basic practices we all know, such as reducing the complexity of the algorithm, by reducing the number of data input and output operations, by changing the behavior of the algorithm based on available resources and workload, and using effective data structures like hash maps for quick lookups and balance trees for quick insertion and deletion operations. Low carbon footprint. The relationship between energy emission and carbon footprint is direct and significant. The more energy a software uses, the higher will be its carbon footprint, especially if the electricity is being sourced from non-renewable resources. Green software methodology provides a framework for implementing these principles that we just discussed. So life cycle assessments and managements basically mean proactively including energy consumption, resource utilization, and carbon emissions as key metrics in the various phases of software development through design, coding, testing, and deployment. This helps with the next point, optimizing energy intensive code. When we do apply these metrics early on in the software lifecycle, we are able to identify energy hungry components and optimize them accordingly. An example of this is tech giants today at data centers are using machine learning to achieve cooling requirement efficiency and developing environmental impact metrics. Of course, without clear metrics, it is difficult for organizations to understand their environmental impact. When an organization translates its carbon emissions into, its energy consumption into carbon emissions, it helps them better understand their environmental impact. Plus, it can also drive decision making on energy efficient practices and technology investments. Choice of programming language and frameworks, we will come to this in a bit later. Advocating and educating green software practices to software developers can foster a culture of sustainability within the community, which we very much need. Using simulation and modeling for impact prediction and analysis during the development and deployment phase of the software can help better understand the trade-offs that might be involved. User behavior and environmental footprints, users need to be educated on how to use a particular software more effectively. Policies and regulations in green software engineering basically encourages incentivizing and enforcing compliance to energy efficient standards and green coding practices to lead organizations on a greener path. Here is the impact of programming languages on energy efficiency. As we see, compiled languages perform better in terms of performance and energy efficiency when compared to interpreted languages. Languages with support for just-in-time compilation can optimize code at runtime, but they may add resource overhead. Languages with support for garbage collection may introduce pauses and additional energy consumption. Languages with manual memory management can be more efficient if they're managed correctly. Languages with support for concurrency and parallelism perform better both energy-wise and time-wise. Languages that optimize low-level operations are preferable for CPU-bound tasks, whereas languages with efficient asynchronous support are more preferable for IO-bound tasks. The second figure depicts the energy consumption analysis of different programming languages. Now, as we see here, the percentage difference between the efficiency of the most efficient language C and the least efficient language Python is about 4,000%. Now, since they serve different domains and use cases, it is not exactly fair to compare them apple to apple. And although it should be a very important consideration, it doesn't always mean that it's the best idea to go for the least energy consuming language. Reason behind it is, take web UIs for example. They cannot and should not be created in a compiler language, right? And Java with its mature ecosystem and just-in-time compilation is a very good match for high trading frequencies, financial modeling, and enterprise level applications. Right. Object-oriented programming and design patterns dominate large-scale software design, mostly owing to their benefits such as code reusability, maintainability, improved scaling, and they also improve communication among engineers. However, the impact of these design patterns on performance and energy consumption is often overlooked. The increased abstraction layers, memory and resource overhead, and over-engineering risks can actually hurt these properties. So more research is required to optimize design patterns to become more energy efficient while still retaining their clear and undeniable benefits. We now have some interesting research data. This is the OOP design consideration for energy efficiency as concluded by an experiment at the University of Texas. which says that inheritance has negligible impact on performance and energy efficiency, so we are good to use it. Virtual functions and dynamic binding slightly decrease performance and energy efficiency, but should be good to ignore. Overloading, on the other hand, significantly decreases performance and increases energy consumption, and hence should be used with caution. Certain design patterns have marginal effect on both performance and energy efficiency, so they can be ignored. However, flyweight design pattern greatly improves both of these properties, while decorator design patterns hurts these properties and hence is less preferable to use. Next are the experiment results from the research at University of Delaware. These are the energy usage measurements of design patterns obtained by running the application before and after the application of design patterns for 15 such patterns. We see here that the effect of design patterns vary greatly. While some patterns like builder, factory method, and prototype have negligible impact, others like flyweight, decorator, abstract factory have marginal to significant impact, with decorator particularly showing high difference. There's another research from the University of Edinburgh which proposed a transformation to the decorator pattern, and it marks an energy efficiency improvement by 12.3%. The way they achieved it was by replacing multiple object constructions for the object and its decorator by a single object construction. The effect of patterns vary based on your software's functionality and the way it's applied. So we can also, like we saw in the example, it is ideal to, before you apply a pattern, just consider the energy efficient aspect too. To conclude, how to eco-optimize your design patterns. First is choose patterns that are energy efficient, like we saw for flyweight, should be good to use it. Optimize high-cost patterns, like we saw the example of decorator. Instead of applying it as is, maybe tailor it to the specific need of your software and see if that helps. Assess before apply. Apply design patterns only when necessary to avoid over-engineering risks. Combine patterns thoughtfully as it can further increase complexity. Leverage profiling tools to understand the impact of patterns and in turn fine-tune their implementations. Despite its clear benefits, there are challenges to green software engineering being widespread. Some of these are the lack of green practices, for example, not incorporating energy metrics early on in the software development life cycles. To mitigate this, obviously, we should encourage adopting these frameworks, principles, and practices into our software's life cycle. And one way to do so would be to involve your stakeholders in such discussions and highlight the long-term benefits of these practices. Legacy systems and technical debt. A lot of systems today are created on outdated architecture and technologies, and they were designed without really keeping sustainability in mind. It can be very costly and time-consuming to refactor such systems to be more energy efficient. One mitigation for this could be to take an incremental approach, meaning optimize the high-impact components first instead of rewriting the whole application at once. Lack of objective coding standards. Of course, inconsistent coding standards do not really give developers a direction to move in, and they also encourage energy-intensive programming practices. The mitigation to this obviously would be to have comprehensive coding standards that are regularly revised to incorporate any new findings or new technologies that might help. Accurate measurement of impact. Without proper metrics, it might be difficult for organizations to justify the investments they made in eco-friendly practices. And it also impends to strike the balance between economic feasibility and environmental responsibility. One way to achieve this is to take data-driven, insightful decisions and to demonstrate why in the long run these practices do help all of us. There's also engaging with the standard bodies to develop and promote the use of universally accepted metrics on environmental impact of software. Lack of green software knowledge identified as a major challenge. It really limits the ability of the developer to create sustainable products. The mitigation to this obviously would be to encourage education and incentivize education into this field and encourage knowledge sharing through workshops, webinars, conferences that are dedicated specifically to green software engineering. Our role, oh, not done yet, just one more minute. Yeah. Our role as software engineers extends beyond just writing code. We are crafting the future's foundation, and today we saw how this future comes with a responsibility to the planet and the future generations. Green software engineering is not just a technical discipline anymore. It is a call to action. We have the tools, the technology, the creativity, and the knowledge to shape the way and to transform the way software interacts with the world, right? By optimizing energy efficiency of our systems and by advocating green software practices, we can transform IT into a force for good, not just for our end users, but for the earth. The changes may seem small, an optimized algorithm or just an energy-aware design, but the collective impacts are monumental. It's not about perfection, it's about progress. So let's rewrite the narrative.